Good morning, physics class. All right, we got video number 2 for this week. We're going to talk about index of refraction and kind of what that means. We'll get into Snell's law in the next video, but this one hopefully will be a pretty short one, talking about index of refraction. So what the heck does that mean for our waves and for our refraction? So what an index of refraction means, it means basically how hard is it to move through that material. All right, so you'll see that this is given an n value, okay? So this is the n, and our formula for this is just n equals c over v. C being the speed of light, and then v being the actual velocity of how fast the wave moves in that actual medium. So as an example, in air, speed of light is 3 times 10 to the 8th. So our n value for air would be 1. In the sense of like air moves exactly the same, light waves and sound waves. Okay, but light waves move the exact same speed in air as they do in air. Okay, that's our baseline as we use air. Water, like light waves move slower in water. Okay, not nearly as fast. Okay, and an n value for water equals 1.33. That's water. Which basically means, again, if I want to try and find the speed of how fast light travels in water, you would take 3 times 10 to the 8, okay? And then you would divide it by, because again, if you ever want to find the velocity of something, or if you want to switch this, again, you can always flip-flop these two in your formulas, okay? So if you went 3 times 8 divided by 1.33, you'd find the new velocity for that actual thing. Okay, so what is an index refraction? It's basically how dense or how much slower waves move in that actual medium, okay? All right, so I'm going to do kind of go over a couple questions from our worksheet that kind of shows how to do this. First, I'll kind of show you on the PowerPoint as well where we got this. So if I show myself and then pull up this right here. So there's the index of refraction, just again talking about air 1.0, water 1.33, and then glass, okay, depending on the type of glass, but usually is around 1.5, okay? So again, it gets even slower in glass, okay? There's a little formula. All right, let's go to our little worksheet, and let's go to this one right here, I think it is. Yeah, so this is the worksheet right here. I think in yours it'll be called like refraction questions number 2 or part 2. And we have some index of refractions here as well as some questions. So let's talk about this for a second. So again, these are just indexes of certain types that we have. So again, air, 1, water, 1.33. We have some glass at 1.5, some other glass at 1.6, some very, very strong glass at 1.7. And then you can see diamond. Diamond has an index of refraction of 2.45, so it's very, very hard to move through that, okay? Let's do a couple questions here, though, that hopefully should be pretty easy. These questions usually go quite well. So if I go to question 2 here, where I'm going to use this actual thing. So we're not talking any angles at all. There's no angles in these questions. It's just talking about velocity and the index of refraction. So it says light traveling through air encounters a second medium, which slows it down to 2.7 times 10 to the 8. So that's slower than your 3. What is the index of refraction? Okay, so if I go n equals 3 times 10 to the 8, because that's the speed of light, over 2.7 times 10 to the 8. Whenever these are the same, you can just kind of ignore the times 10 to the 8. And that's what I'm going to do right now. All you have to do is just go 3 divided by 2.7. And so when I do that and I get an answer, I get an n value of 1.11. Okay? So that is the index or refraction of whatever this new medium is. All right, over here it says light travels through a substance at 1.97 times 10 to the 8 meters per second. So that's the new velocity. What is the index? And then if you go back up here and see what kind of actual material it is. So same kind of thing here. 3 times 10 to the 8 over now 1.97 is what it's new traveling at. I get an answer, I think 1.52. 1.52. N value equals 1.52. All right, and so what does that match up there? It matches our crown glass. So this substance that it actually moved through would be the crown glass. All right, so there's how to do those 2 questions. And how to actually find a new n value just based off of speeds. Let's do one more question, which is kind of on the backside, where it gives you the n value and you have to figure out what the new velocity is. So I think over here, yeah, question 7. question 7 here. It says, what is the velocity of light in meters per second in material with an index of refraction of 2.0? So again, here's our formula. N equals C over V. I have the N, 2.0 equals, I still have this, 3 times 10 to the 8. I'm looking for that velocity though, okay? So I'm looking for that velocity. Again, anytime you have a formula that looks like this, where your actual variable is on the bottom, we can kind of switch and flip it here, switch and flip. And so now to figure out that velocity, I have 3 times 10 to the 8 over that 2.0. And so when I go, again, you can kind of ignore the 10.8 for now and just do 3 divided by 2. If you ever get a decimal, then you might have to redo it. But I mean, if you go 3 and put 8 zeros and then divide it by 2, you're still going to get like 1.15 and then 7 zeros. So it kind of works out the same. But in the end, you're going to get an answer of 1.5 times 10 to the 8. Okay, or 1, 5, 3, 4, 5, 6. Or it'll look like that on your thing. Either one's fine by me. I'll accept absolutely both answers. Okay, so hopefully this index refraction isn't too hard for you guys to kind of understand what the meaning of it is. Again, it's just how dense something is that slows down that actual light wave, or sound wave, or water wave. But again, it's all going to affect it, okay? So for these questions, we're not looking at any angles. We're just looking to try and figure out that index, or use that index to try and figure out the velocity. So not too bad. All right, cool. Next video, I'll talk about Snell's law, which goes a little more into detail and actually has some actual angles in it. All right, thanks, class. Let's get back to this. All right, cool. Thanks, guys.